Okay,
All
great.
right, so we're gonna dive right in. If you have questions as we're going through the program, please type them into the comments and we will address them at the end of each portion of the presentation. So when I introduced myself a second ago, I said I'm a maritime archaeologist. Now, what does that mean? Maritime means of or relating to the sea or the water. And an archaeologist is someone who studies human history through man-made objects. So if we put those two definitions together, a maritime archaeologist studies things that have been made by humans that are either underwater or have to do with the sea or the water, like shipwrecks. So maritime archaeologists do lots of different things as part of their job, things like historical research, drawing artifacts or the sites that we look at, taking lots of video and photo data, and artifact conservation, which is when after an artifact is removed from underwater, we take care of it so it can survive in an oxygen environment. And then the last thing is archaeological survey and excavation. So we are looking at, documenting, drawing the sites, and sometimes excavating or digging things up out of them. And when we do that, that usually means we have to go underwater using scuba equipment. So I'm going to talk today about a few pieces of the equipment that we use in my job. So first things first, when we are going underwater, we need to do everything we can to protect ourselves from the elements around us and the temperature. If you are in the Great Lakes and have been in the water here, you know how cold it gets. So we are very careful to make sure we are keeping our body temperature as warm as it can possibly be. So there's two types of suits that we use for that. One is a dry suit and one is a wet suit. Now, the definition is in the name. So if you're wearing a dry suit, you have latex seals at your neck, wrists, and ankles, and that does not let any water in. So the only part of your body that's going to get wet is your face. If you're wearing a wetsuit, it's the opposite. It is going to let water in. If you wear a dry suit, you usually do that if you're a person that gets cold easily because you can wear layers of clothing underneath, and so you stay nice and warm. I don't have that issue, so I wear a wetsuit. My wetsuit is made out of a material called neoprene, and this traps a thin layer of water between the suit and my body, and it uses my body temperature to warm that water up. So that's what helps keep me warm underwater. So this is the first piece of my suit. It goes from my shoulders all the way down to my ankles. And this is the second piece that goes over the top. So it's a little shorter, but it puts a double layer of material over my vital organs. So my lungs, my heart, everything that's in my torso. So you can see how thick it is. Each piece is about 3.5 millimeters. So when you put that together, that's 7, which is almost an inch of material on my body. Now, I float pretty well as it is, but when I'm wearing that suit, I am very buoyant, which means I float very easily. So positive buoyancy means you're floating, and negative buoyancy, so the opposite, would mean we're sinking. And we don't want that to happen. So divers have another piece of equipment that they use to help control that, which is called the buoyancy control device. So this looks like a really crazy or fancy vest or backpack, and it does a couple different jobs for us as divers. So the first thing is it holds the tank in place. So this tank back here is holding a mixture of pressurized oxygen and nitrogen and other gases. And this is what I'm breathing while I am underwater. The air that's in here is under a high amount of pressure. So I'm going to turn this on so you can hear how loud it is, but it is going to be loud. So if you don't like loud noises, cover your ears. That was just with a little turn of the nozzle. So the air is packed super tight into this tank, and that makes it really heavy. So this tank weighs about 25 pounds when it's full of air. Now, for some people, that's enough weight to keep them underwater. But for me, I need a little more. So the second job that my BC does is it has an integrated weight system, which means I can add weights to my vest. So I have two little pockets here at my shoulders that each hold 1 pound, and then the pockets down here at my sides hold up to 10 pounds each. And I have a bunch of little bags like this that are filled with little pieces of metal. So this one weighs 5 pounds. And I can add those to help keep me underwater. So that's the second job. Sometimes people's BCs don't have an integrated system like mine, so they will have a belt that they can attach weight to and just wear that around their waist while they're diving. And then our third job that the BC does is it can be inflated and deflated to help control our buoyancy underwater. So I'm going to show you that right now. So we talked about this a minute ago. When we are positively buoyant, we're floating. And when we're negatively buoyant, we're sinking. But as scuba divers, we don't want to be doing either of those things. We don't want to be shooting up to the surface, and we don't want to be sinking and running into the things that are on the bottom of the lake or the ocean. So we want to achieve neutral buoyancy, which means we're not sinking, we're not floating, we're hovering underwater. So in our BC, I just attached my regulators, which I will talk about in a second, but one hose goes from the tank here into my BCD. So you want to watch this part right here. So I'm going to inflate it with this red button. Did you hear it fill with air? You saw it get bigger there. And now I can deflate it with the white button. So as I do that while I'm diving, I can control with very little movements how much air is in my BCD. So I said regulator a second ago. That's just a fancy word for control. So you heard in the tank how the air was under super high pressure, and that would not be safe to start breathing. So the regulator hose helps regulate or control that. So it's got 4 different hoses. The first is to this. This is my primary regulator. This is what I use to breathe. Mine even has a little mouthpiece on it, so it fits specifically into my mouth. And then this is my secondary. So if something happens to this one, I can use this one. Or if I'm diving with a buddy and something happens to their air or they run out, they can use this one and we can share. So that's hose number 1 and hose number 2. Hose number 3 is attached to my BC. So that's the one we did with the button, inflate, deflate. And then hose number 4 is attached to my gauge and dive computer. So at the top, it's not on right now because I'm not underwater. But once I go underwater, it will tell me the depth, the water temperature, and some information that I need to be able to dive safely. And then underneath, if you can see here, is the gauge, and it's just like in your parents' gas tank in their car. So it's telling me how much air is in the tank. And once it gets to the red section there, so 1,000 or lower, that means that I need to start thinking about ascending and going back to the surface, because running out of air is not a good idea. Now, we talked about those main elements of my scuba equipment, but there's also some smaller pieces that are really important. We talked about how heavy this gear is. So wearing something on my feet to help propel me through the water is very important. So I have little boots that I wear to help fit in my fins. And then these are my fins. If I tried to swim in all of that gear with just my feet, I would not go anywhere. So these fins help me push the water and propel myself as I'm scuba diving. We talked about neoprene earlier, what my suit is made out of, and another piece that's made out of that is my hood. The hood, just like, does the same thing underwater that it does on the surface. Keep your head warm. You lose heat fastest through your head. So when we're underwater, it's really important that our head is protected and staying nice and warm. Another thing that's made out of neoprene are my gloves. Some people like to have really thick gloves that look more like mittens, so that way their hands stay nice and toasty warm. I don't like that. For my job, I need to be able to move my hands quickly and efficiently. So I have nice thin gloves that allow me to move just as quickly without as with wearing the gloves. Some other equipment that I carry is my dive knife. This is really important if I ever get stuck or tangled up in something. I wear that on my leg and I can unsheath it and cut myself out. I haven't had to use it yet, and hopefully I never will. Another piece that's really important is a compass. Sometimes when we're underwater, we have great visibility and we can see for hundreds of feet. But sometimes it's so bad you can't see your hand in front of your face. And when you're diving in those conditions, it can be really disorienting and hard to find where you are. So a compass is really important. Now, last but certainly not least, is my mask. We want to be able to see all of the amazing things that are underwater. And a mask helps us do that. So it keeps water out of my eyes and magnifies everything just a little bit so I can see details even better. Now, some of you might be asking, why does she have a snorkel? She can't use a snorkel underwater. Snorkels are important because sometimes when we're going to a site, we have to swim to where we're going. And we don't want to use up the air in our tank. So we use our snorkel instead to breathe along the surface. And then we can save all the air in our tank for when we get down to the shipwreck. So those are a couple of the pieces of equipment that we use. And we've talked about how fun and exciting diving can be, but diving can also be dangerous. So I want to talk about that for a second. Humans are not designed to be underwater for long periods of time. So our bodies have had to adapt, and we have equipment that helps us do that and techniques to keep our bodies safe while we're underwater. Safety should always be our #1 priority when we're scuba diving. We never dive alone. We always dive with a buddy, and we are always thinking about protecting ourselves and that person. One of the ways we do that is by taking different classes. Scuba divers have all types of things that they can learn. And by taking the classes, we get more information about how to scuba dive well. And we also get information about different opportunities and things that might happen underwater that we can prepare ourselves for. Some of the classes include cave diving, shipwreck diving, night diving, and deep diving. So there's lots of different options for people to choose whatever they want to do. Another thing that we have to deal with is water pressure. Our bodies are used to being in air, which doesn't put a lot of pressure on us, but water does. Have you ever dove down to the bottom of a swimming pool and your ears started hurting? It's not fun. Our inner ear is one of the most sensitive parts of our body, and it's not used to having a lot of weight on it. So when we feel that pain, it's a signal to our bodies that there's a problem. So what scuba divers do is we apply pressure from inside our body to equalize or cancel out the pressure that's coming from the outside. So try this with me. You're going to pretend to blow your nose very gently, and when you do it, you're going to plug your nose just like this. If you did it right, you should hear a little pop pop in both of your ears. So you just applied the same amount of force from inside your body to equal the force on the outside of your body. So you equalized your ears. So if you dive into a pool and your ears are hurting, try that and it should make it better. When I'm scuba diving, I equalize about every 10 to 15 feet. That helps protect my ears and keeps me aware of how deep I'm going underwater. Now, the last thing we have to talk about is the bends. I talked earlier about how the air that I breathe is a mix of oxygen and nitrogen. Nitrogen is not something that is supposed to be in our bodies, but water pressure helps. When we're under pressure, nitrogen can dissolve into our bodies without causing a problem. But if that pressure changes, so if we go from say 100 feet underwater to shooting up to the surface, that nitrogen doesn't have time to dissolve and it has nowhere to go. So it turns into little bubbles in our blood that then can travel to our brain or our heart and cause really serious problems. So in order to avoid that, scuba divers make sure to ascend or go to the surface in a slow and controlled manner. So by doing that, we are decreasing the water pressure very slowly, and we're giving that nitrogen time to dissolve out of our bodies and time for us to rest as we're getting to the surface, so we get there safely and without any medical complications. I've told you guys a lot about scuba diving today. Thank you so much for listening. And if you have any questions, go ahead and type them into the YouTube comment section now, and I'll answer them for you. So Wendy, do we have any questions?
Yes, Sophie, we have one question so far.
Awesome.
From Ivana B. And the question is, referring back to when you were talking about the weight of your tanks, the question is, what if 25 pounds is too much?
That is an excellent question. So if 25 pounds is too much, you're going to have to be really familiar with using your BCD. So what I was talking about with the vest, you would have to keep this inflated the whole time when you first started. So that's helping to counteract the amount of weight. So that would be extra air. Like when I start, my BCD is completely deflated. There is no air in it to help me get to the bottom. So if 25 pounds is too much, you would start with this fully inflated, and then as you breathed air and the tank got lighter, you would be able to put less air and slowly deflate in little puffs your BCD. That's an excellent question. But I don't think I've met anybody where 25 pounds was too much. But sometimes when kids or younger people are scuba diving, that might be something that they'd have to worry about. Are there any other questions?
Yes, we have another question.
Okay.
And the question is about whether deep divers, where they're going really deep, do they have bigger tanks or do they take extra tanks? How does that work?
That is a fantastic question. So there's a couple different things. The short answer is yes. If you are going deep, so if I took that tank that's on my suit right now to about 120 feet, I would be able, by the time I got down there, I would probably stay there for about 10 to 15 minutes, and then it would be time for me to start going back up because the air in my tank, that's all it would allow. So there are tanks where there's two, so they're attached to each other, so you're doubling the amount of air. And then there's another, even more advanced type of equipment called a rebreather. And a rebreather is creating the air. So it's this big machine that you're wearing on your front and on your back, and it does not create bubbles because it is recycling the air that you are breathing out back in to your body. So it's super complicated and very scientific, but it allows for divers to be underwater for 3 or 4 hours at a time. So it's very important technology, especially for studying those deeper shipwrecks. And if it's a shipwreck that's even so deep that humans can't get there, we have robots that we use to help us take video and pictures called ROVs, which are remotely operated vehicles. So those, because they don't have to worry about supporting a human, can dive as long as we can control them. Any other questions?
Somebody else also asked about rebreather gear, but they think that you pretty much answered their question.
Awesome.
what you just
Yeah.
said. Yeah. I think it's pretty cool when you think about recycling air. You know, we think about recycling other stuff, but the
Yeah.
thought of recycling air is like pretty cool science.
Definitely. All right, so we can probably wait another couple seconds. And then if we don't get any more questions, we'll switch over to Wendy's portion, which is going to do a science experiment to show us at home how some of this science works that I just talked about.
We have a question about the difference between freshwater and saltwater in your diving. Is there a difference in what you use or what that feels like?
Yes, so saltwater is more dense than freshwater. So that takes into effect how much weight you have to use. So I have to use more weight when I'm diving in freshwater to keep me underwater than I would with saltwater. Temperature-wise, it doesn't really make a difference because there's saltwater places that are really cold and saltwater places that are really warm. But obviously, you also have to think about saltwater can't freeze. So unlike Lake Michigan, where ice diving is really popular, you're never going to get that opportunity in saltwater. So that's a couple things that are different between the two. And saltwater is a lot harder to clean off of your gear than freshwater. All right, so should we turn it over to you, Wendy?
I think so. And just a reminder to people that if they think of something else while we're doing our experiment, they can always come back and ask questions again to you after my experiment is done.
Definitely. All right, so we'll turn it over to you.
All right. Let me just get my window shrunk here a little bit. Okay. All right, so you saw Sophie's dive equipment and heard her explain how that equipment is related to buoyancy. So we're going to apply what we've learned with our own experiment. We're going to create our own diver using the following materials. And just a note, if you have these materials ready, you can do the experiment along with me. If you don't have them right now, they're simple enough that you could gather them easily together around your house and do the experiment on your own later. So I'm going to introduce what those are right now. First, you're going to have a clear plastic bottle. This was one, it's a kind of a squishy plastic, it had water in it. And I was able to peel the label off. And so it made for a really great bottle. This one, you're going to want to have water in it. So right now, if you're doing the experiment with me, go to the faucet and get your bottle filled up, not all the way to the top. I'm holding this, I think you can see it. There's about an inch of space there, maybe a little less than an inch. So leave a little bit of space. You don't want it filled all the way to the tip top. When you get it filled with that little bit of space of air, then you make sure to close that cap off nice and tight. Don't squeeze while you're doing it. And just a reminder that you're probably working somewhere near your electronic device. So, you know, we're working with water, so be really careful. Maybe lean back a little away from your keyboard or whatever you have in front of you. Okay, so you've got your bottle, you've got water, and you've got an air space at the top that's maybe about an inch. You have your cap on tight right now. All right, set that bottle down. The next thing you need is a bendy straw. So at the store, you can get them at like the dollar store. I'm not a big friend of straws because I see them being used as litter, unfortunately, but this is a cool piece of science here. So we're using them for a good purpose and we're not going to litter with them. So we're going to take that straw at its bend. We're going to bend it. And then we're going to take a pair of scissors. And that scissors is going to cut exactly where the bent part meets the rest of the long end of the straw. So I'm going to cut up. And what we end up with is our little diver. It's your straw that is now shorter and bent in half, so it has like equal parts. Okay. The next thing you're going to need is a set of 4 paper clips. And there doesn't have to be anything fancy about those paper clips. They can be metal, they can be plastic. And I use just regular size paper clips. They're not ginormous ones. They're just regular paper clips. Okay. Okay. So just a reminder as we work on this that we are being careful around our electronics. Okay. All right. So you have filled your bottle with water, hopefully, by now, and you've left a space of that air. You now hopefully have cut your straw and it's in that bent position. And this is our diver. So now we're going to take one of those paper clips and we're going to open it just a little bit, because what we're going to do is insert one end of that paper clip into one open end of the straw and the other end of the paper clip into the other open end of the straw. And that puts our diver together. Okay. And on that little loop that's now sticking out, now we'll be able to attach the other paper clips. So I'm going to do this. I'm going to take one paper clip and I'm going to hang the other couple of paper clips from that one. So I'm going to give you a second to do that. For those of you who are doing this with me at home, I don't want to be going too fast for you. So you can see how I have those just one kind of hanging from the other. All right. And then now we're going to take the one paper clip and we're going to, let me back up a little bit. We're going to hook that into the paper clip that's sitting in part of your diver. Okay. So now we've got our diver. The diver has some weight now. Remember how Sophie had those sandbags on her BCD? Okay, we've added some weight, not sandbags, but we've added paper clips. But we also have trapped air. Remember how Sophie had air in her tank? Well, we've got trapped air right here in our straw. Okay, so here we go. Now we're going to take that bottle that we had. And again, be careful. Do not squeeze the bottle as you open the cap. You don't want water come squishing out. Okay, so open that up. You're going to take your diver. And that diver is going to go in clip first. So those clips that are hanging, those go in first. And in goes the diver. You should see that your diver is just floating at the surface. Now we're going to take that cap, put it on nice and tight. And what you're experiencing now is positive buoyancy. Your diver is floating at the top. All right, let's take a couple of those physics principles now and apply them to what we're doing. Archimedes' principle says that the volume of your diver is equal to the volume of the water it's displacing. That's what it means to be positively buoyant, right? So to be a diver, though, we want to become neutrally buoyant, as Sophie was talking about. So we're going to apply another law of physics called Boyles Law to make that happen. Boyles Law states that as pressure changes, the volume of gas in the diver's body changes too. Here's how we're going to accomplish that. I'm wondering if you've already figured it out. We're going to squeeze our bottle on the outside to increase the pressure on our diver. As we squeeze, it decreases the volume of air trapped inside your diver. That makes your diver denser than the water it's in. And in that way, you can see your diver descend. I'm going to give you a minute to try that a few times. When Sophie was talking about diving on shipwrecks, though, remember, they don't really want to like just dive right down to the bottom of the lake and sit there at the bottom. That would be negative buoyancy, and that would be like sinking, okay? They want to be neutrally buoyant. A lot of times they want to be hovering over various parts of the shipwreck, and they don't want to be all the way down at the bottom of Lake Michigan or Lake Superior, wherever they are. So we want to be neutrally buoyant. Now, you and I doing that, this takes some thumb energy, okay? We want to see if we can get just enough of a squeeze that we can get our diver to hover. Can you do that? If that's, and I know there's my diver, can you see it? It's off to the side right now. If your hands get tired, you may need an adult to help you, or you may need to just take turns with a friend. Okay, so I've got my diver hanging in there, hovering, looking at the shipwreck. It's pretty cool. All right, now remember, Sophie explained that divers need to rise slowly back to the surface in order not to experience those nitrogen bubbles called the bends. All right, now we don't want our diver to just pop back up to the top. Our diver would get bends from that. All right, we don't want that to happen. So let's get our diver back down, get it hovering, and let's see if you can very carefully and slowly release your diver back up to the surface. There, your diver has just experienced positive buoyancy, a little bit of negative buoyancy because you probably popped all the way down to the bottom to begin with, and then experienced neutral buoyancy, and we safely got our diver back up to the surface. Now, if you think that experiment was kind of fun and you want to do it again and do it a little differently, a couple variations you can think about. I've seen examples where people took that straw and like they molded clay around it so it looked like a fish. I've seen people use pipettes or eyedroppers to do this experiment. I've seen people add little plastic discs that can be used like propellers. If you cut little slots into them and you squeeze, it'll spin around as it goes down because it has a propeller on it. So there's actually some pretty cool stuff you can do to experiment with this. But I hope this was helpful for you to get an idea, just a simple experiment that works a little bit with Archimedes principle, a little bit with Boyles Law, and gives you a little bit better idea of what's going on with all that equipment that Sophie was showing us.
All right, so it doesn't look like we have any questions, but people still may be playing with their Cartesian diver. So we'll give it a second because it's so fun.
It really is.
And that's a really good test of control, the slowly letting it ascend to the top of the bottle. And it helps think about, because obviously in the bottle, that's a lot less space to do that than when I'm 60 feet underwater and have plenty of time to rise 60 feet back up to the surface. All right. I'm not seeing any questions. So I guess we can just say thank you so much to everybody. Thank you to UW Science for putting this on. Oh, we do have a question. Yay. Are there any weight restrictions on how heavy you need to be when you dive? So I guess I'd need a little more information with that question, like weight restrictions for the person or the amount of equipment. I mean, I have been diving with people of all shapes and sizes, so it's just really important to know how much weight you need personally to stay underwater, because there is nothing as frustrating as getting to your dive site and finding out that you don't have enough weight to be able to get underwater, because then that you can't do the dive. Or you can, but you'll be snorkeling. You'll just be on the surface. So one thing that's really helpful, here I can grab mine, is scuba divers document information about each of their dives. So in something called a dive log. So this is my dive log. It's got all of my certification cards in it, and then it's got a page for each dive, thank you, for each dive that I've done. So I write all of the different equipment down. I write what weight I was using. I write the depth, the size of the tank, so that helps me remember. So if it's been a really long time, since I dove, say, in salt water, I have this information written down so I can quickly remember, hey, I was using this size of a tank and I needed this much weight to help keep me underwater in salt water. So that's an excellent question. Thank you. And then it looks like we have another one. What do you need to do to lift items from a wreck? One from which you can legally retrieve items. So that's an excellent question. We have these, if it's a small item, we just carry like a mesh bag with us, and then we'll put it, the artifact or the object in the bag, and then bring it up. If it is a larger item, we have these things called lift bags. And so it looks like a parachute, and we take them underwater, fold it up, and we attach them to the object or to like a crate, and then put the object in it. And then we inflate the parachute slowly. So I would use my secondary regulator, the one that isn't in my mouth, and I would slowly pump air into the parachute to help raise the object. And then I would go to the surface with it to make sure that I was staying with that object all the way up to the surface. But this is a really good time to talk about when you said which items we can legally remove. So you civilians cannot legally remove things from a shipwreck. Shipwrecks are protected by the state in whose waters they are currently sitting. So for us as archaeologists, when we want to remove something, we even have to go through a whole permitting process, because once that artifact comes up, we are in charge of taking care of it. So all of the conservation, where it's going to go, if it's going to be in a museum collection or an exhibit, all of that has to be planned out ahead of time, so the artifact isn't brought up and then nothing happens to it. That's a really good question, though. Thank you for asking. Do we have any others? I don't think so.
No, I didn't see any others either, Sophie.
Okay. Well, thank you so much, everybody, for tuning in. I hope you enjoyed the science of scuba diving. We want to say thank you to UW Science for putting on this awesome event, and I hope that you guys had fun and were able to look at some of the other videos as well and see the awesome science that's being done here in Wisconsin.
Thanks, everyone. Hope you had fun with the experiment.
Bye.
Bye.